Hello, am I audible?
Yes, sir.
Yes, okay. So, guys, today I'm going to start with the declaration. Okay. So, first of all, how to what a step of ML project means how to start the ML project. So, step for machine learning projects. Okay. So, first step is first of all we need data. So, collect data. Collect data. You can collect data from anywhere, like from website, from employee. Okay. The second part is analyze. Analyze the data. Okay. Means EDA. And what is EDA? So EDA is a exploratory data analyst. So inside this, the first step is first of all check our data is numerical or categorical. Exploratory data analysis means inside this we are going to check our data is numerical or categorical, then check the missing values, then check the outliers, distribution of the data is balanced or imbalanced. Okay.
Sorry, sir, but I did not get E for data analysis.
Exploratory EXPLORATORY. Okay.
Thank you, sir.
Yes. You all know how to check the data is numerical or categorical. The second part, missing values. Missing values. First of all, check there is any missing values inside my data or not. If there are so many methods to fill the missing values. One is with the help of mean. Second is the help of median. The third one is mode. So the question is when we will use the mean, median, and mode. Okay. So first of all, check before the filling the missing values. First of all, check there is any outlier inside my data or not. The third one is outlier. Okay. If outliers are present and my data is numerical, so then you can use this median. Okay. If there is no outlier inside my data and missing value is present, then and my data is also numerical. So then you can use this mean. Okay, and my data is categorical, and then you can use this mode. Okay, clear?
So can you repeat that? If the data is categorical
If the
and
data
there
is
is missing value,
if in my inside my data there is missing values, okay, and my data is categorical, then you can use mode for filling the missing values. Okay, suppose my data is like 1 2 3 3 2 1 3, and there is nan value here 1 3 also. Okay, and what is the mode of this? Mode means find the most frequent values inside the data. So most frequent value is 1 3 is 1 2 3 4 times. Okay, so fill this value with 3. Okay, so this is a categorical data. If my data is median, sorry, if my data is numerical, okay, and outliers also present, then you can use this median. And why we use this median, let me tell you.
but sir, this is all numerical. Categorical is something like gender of female and male,
This is
and
because inside the machine learning, suppose you have like male, female, female, male. Okay, so machine learning wants the numerical data, not a categorical data. So convert your this data into this one, 0 1 0 1. So this is also the category. Okay,
okay, sir.
if you put your data like this, string values, then you will get some error. Okay,
Okay, sir.
yes. Now what will be the impact when we use median and mean? Okay, suppose if I have like this type of data, 3 4 4 5 6 7 8 9 10. Okay, now there are no outliers. Okay, so what is the mean of this? 5.5. 5.5. Okay, suppose inside my data one is another variable is present here 100, and this is the outlier. And how we can find the outliers? With the help of IQR, interquartile range. Okay, I will tell you in the next class. Okay, outliers, what number 5 means? Outliers means, suppose,
So what are exactly outliers?
wait, suppose inside my data, this is my data. Okay, so this is a normal data, but there are so many difference in between 100 or 10, and if you are going to find the mean of this, then the answer will be like 155 divided by 11. Okay, so my answer will be 11 11 4 11 4, like 4 point something, 4.1 something. Now and the previously my mean is 5.5. So you can see the difference between this one mean. Okay, if in my data outliers is present, then the difference you can see. So at that point of time, use the median. And what is the median? Middle values. Okay, you all know what is median.
Yes, sir.
Yes, so fill with median. Otherwise, if my data is clean or there is no outlier, then use the mean to fill the missing values. Okay, Now clear?
Yes, sir.
Yes, sir. So,
Okay. Now come to the, this is one, wait. This is third one. Now come to fourth part. Check the distribution. Distribution.
Sir, excuse me.
Yes.
Sir, instead of doing missing value treatment first and then doing outlier treatment, can we
No,
do
no,
a first
no.
outlier treatment?
Yes, yes, yes. First do the
Yeah.
outlier treatment. Then you can find na. There is an outlier
Then
or
we
not.
can replace by mean also, right?
Yes, yes, yes.
Okay, fine. Thank you.
Yes. Then check the distribution of data. Okay. My data is normally distributed or like this. Wait. Like this. This is my this data is not normal distributed. Okay, so can check my data is normally distributed or not. If my data is normally distributed, then you can go ahead. Otherwise, change your data into normal distribution. Okay. If you my data like this. Okay, so this is left skewed and this is right skewed. So you can use the log normal distribution, implement log, and you can change your this distribution to the normal distribution. Okay. Suppose this is my data 5. Then apply log. Then you can convert your skewed data in the normal distribution. Okay.
Can you please repeat this applying of log? Like how once you apply the log, it would be, made to the normal values. Is it so?
Yes,
This
if your
graph
data
will
is
be removed.
log normally distributed, then how you can change your log normal distribution in the normal distribution? Okay.
Okay.
So then apply
And
log. Yes.
no, I have one more question. I have found questions like, if you values are given and they ask, is it left skewed or right skewed or normal distribution? How, if seeing the graph, it's easy
With the
to
help
say,
of
but
graph. Yes, with the help of graph. See this na EDA. In the EDA, this one na distribution. Use the
okay.
graph. Then only you can
So
find the distribution. Otherwise,
how
like if
the
your
graph-
data like 2, 3, 4, 5, 6, you can't say like this is normal distributed or is left skewed or right skewed. First of all, create a graph. Okay.
Okay.
Yes.
But how to create that graph?
Graph with the help of there are so many libraries like matplotlib, Seaborn, Cufflinks. There are so many libraries. You can use these
Okay.
libraries and you can plot. Okay. Now the other question, other one is data is balanced or not. This means balance or not. Suppose you have a target variable like this 0, 0, 1, 0, 0, 0, 0, 1, 0. So count 0, 1, 2, 3, 4, 5, 6, 7. 7, 0 and 1, 2. You can say 0, 8, 0 and 2 1s. Okay, now at that point of time, my data is imbalanced. Imbalance means, suppose if you predict your data, your model with the help of this data, then you can check your accuracy. Now your accuracy is like 90 or 95 or 99%. But when you draw like AUC, ROC curve, and there are so many like confusion metrics, and with the help of this, uh, you can check your model is overfitted or not, because your, suppose your accuracy is 99%. Okay, but when you put your any data, always your data output will be 0, because there my data is imbalanced. There are 8 zeros and 2 ones. Okay, so first of all, convert your imbalanced data in the balanced data. Then how you can convert it? Any idea? Shashank, I think you have.
No, sir.
No. Okay, so with the help of sampling. Okay, there are two type of sampling, like oversampling or undersampling. And what is oversampling or undersampling? Oversampling means, suppose if you have a large data, like this type of data, okay, then you can use this oversampling. If you use this undersampling, then it reduce your data. Okay, it will reduce your data, and then you can use this oversampling. If you have 100 or 200 lines of data, then you can use this undersampling. And what is undersampling? Suppose if you have 0 0 0 0 1 0 1 and 1. Okay, now count this 0 0 0 1 2 3 4 5. Well, it's also 0 6. Okay, or now once is 2 times. Once is 2 times. Now undersampling will do one thing, convert your this one data into like 2, and this is also 2. Now you have lost, you lost 4 data. Okay, but if you have like large data, then at that point of time you have like suppose 90,000 90,000 0, and like rest of all 1. Okay, then if you use this undersampling, and it convert your this data, suppose you have 10,000 here, so the undersampling converts your data into the 10,000. So like 10,000 0 and 10,001. Then at that point of time you lost 80,000 data. Okay, so then use oversampling. Oversampling means, oversampling it convert your 1, okay, near to this 90,000. 1 to near to
Are
6. Yes, Asma.
are the oversampling same as overfitting?
No, there is no overfitting.
Oh, okay.
Yes. Oversampling means the sample your data, means your data is convert like oversampling or undersampling means reduce your data or increase your data.
Okay, okay, clear.
So
Oversampling
how we can increase the data?
with the help of this one, na, oversampling. There is a library for oversampling in sklearn.
So sir, it will duplicate the values, or what it will do?
It will do increase the do some calculation, and with the help of calculation it convert your data. Okay, there is a library in sklearn for oversampling and undersampling. You can do with the help of this one. Okay.
Okay.
Yes. Now these all are the things in EDA part. Now come to the third part. come to third part. Third part is choose the algorithm. ML algorithm. Okay. So which algorithm is best for my data? So uh, you can create a different model and check your accuracy, and there are so many like MSE for the regression problem, and like AUC ROC curve for the classification problems. Okay, and confusion matrix also. Okay, I will give you all the glimpse of this confusion matrix or this one. Okay, then evaluate your model. Fourth one is then evaluate your model. Okay, these are the things before creating the model. So now clear, everything is clear.
The fourth point after ML algorithm, what is it in the concern?
Sorry,
The fourth point, yeah, after applying, choosing ML algorithm, do we have to evaluate it?
check your data, like your algorithm is best for this model or not. Check the accuracy. Check accuracy.
Okay.
Accuracy for classification problem. Okay, for regression problem, check MSE. Okay, there are so many like R square also, or there are so many things.
MSE.
Yes, mean squared error. Okay, so everything is clear.
Yes, sir.
Yes.
Okay, so now come to the, my screen is visible now.
Yes, sir.
Accuracy for classification, and then the other things are for
Regression. Because for regression, if your MSE is low, if your error is low, then your model is good. Okay, yes. Yes, now come to the linear regression part. So in the linear regression, we'll use this equation. I think you all know y equals to mx plus c. This is the equation of line.
screen not visible.
Please scroll down your please scroll down your screen.
No.
Okay. So whenever we are talking about linear regression, we are having a data. Inside that, we are having a numerical values. Okay, so linear regression always for the regression problem, not for classification problem. Okay, so suppose in EDA, if you check your data distribution. Okay, now if your data distributed like this, so this is normally distributed. Okay, so this is normally distributed. then at that point of time you use the linear regression. Okay, so linear regression algorithm will you can say will give you more accuracy. Okay, you can use any other model also, but if your data is divided like this, normally distributed, or like, sorry, linearly distributed, then you can use the linear regression. Okay, now what is this M and what is this C? Okay, so C is the intercept. This is intercept. Intercept. And what is this M? This is slope. Slope means slope of line, and this is intercept. This distance. This is intercept, and slope is this. And how we can find the slope? There are so many formula to find the slope. One formula is M equals to y2 minus y1 divided by x2 minus x1. One formula also, M equals to tan theta. Okay, with the help of this, you can find this. And intercept this. What is this intercept? The distance between this one. Okay, so now first of all, calculate the prediction. Like how to calculate this? Suppose if I have a data like this, temperature. Now with the help of this temperature, we can find we are going to find this sales of ice cream. Okay, so this is independent variable or this is dependent variable. Now my data is like 35 degrees centigrade, 40 degrees centigrade, 45 degrees centigrade, 25 degrees centigrade, 15 centigrade, and like the sale is 5K, 10K, 25K, 2K, and 1K. Okay, now this is the independent, this is dependent variable. Now this is my target variable. With the help of this temperature, I'm going to find this one. And this is X and this is Y. Okay, so now take first of all these two equations. Now put your this data in the, what is your Y? Y is 5K. Let me remove this K.